The universe often appears calm when we look up at the night sky. Between galaxies lie unimaginable distances, filled with what seems like empty space. Yet beneath that quiet appearance, the cosmos is constantly changing. Giant galaxies collide, stars are born and die, and invisible forces shape the universe in ways we are only beginning to understand. Every so often, astronomers uncover something so unexpected that it challenges decades of scientific thinking. That is exactly what happened when one observation revealed an enormous, perfectly organized structure stretching across intergalactic space. It wasn't a spiral galaxy, a glowing nebula, or the aftermath of a familiar cosmic explosion. Instead, it appeared as an astonishingly straight trail extending for nearly 200,000 light-years, longer than the entire width of our own Milky Way. Even more surprising, this immense structure was packed with brilliant young stars, all seemingly connected in a way that no known process could easily explain. At first glance, the discovery looked almost impossible. Nature rarely creates anything so remarkably straight on such an enormous scale. The deeper scientists examined the data, the more puzzling the object became. Every answer seemed to raise an even bigger question. What could possibly carve such a massive path across the universe? And what kind of force could leave behind a trail that has never before been observed anywhere in the cosmos? Only by following the evidence would astronomers uncover one of the most extraordinary stories modern astronomy has ever told. The discovery that challenged astronomy. For decades, the Hubble Space Telescope has given astronomers an extraordinary view of the universe. Its images have revealed distant galaxies, exploding stars, and ancient light traveling across billions of years. Most observations deepen our understanding of known cosmic processes. But every now and then, Hubble captures something that simply doesn't fit the rules. While examining a distant galaxy, a team of researchers noticed an unusual feature that immediately stood out from the surrounding space. Extending away from the galaxy was an incredibly long, narrow band of bright blue stars. It wasn't curved like the graceful arms of a spiral galaxy, nor was it scattered like the debris left behind after a galactic collision. Instead, it formed an almost perfectly straight line cutting across the darkness of intergalactic space. The scale alone was breathtaking. The structure stretched for nearly 200,000 light-years, making it roughly twice the diameter of the Milky Way. Yet despite its enormous size, it remained remarkably thin and uniform. Even more surprising was the age of the stars. Detailed observations showed that they were overwhelmingly young, hot, and blue, clear signs of recent star formation. That created a major scientific puzzle. Galaxies normally contain stars of many different ages. Older red stars exist alongside younger blue ones, creating a balanced stellar population built over billions of years. But this structure looked completely different. It appeared as though millions of stars had formed within the same narrow corridor over a relatively short period of cosmic time. To astronomers, this wasn't just another unusual observation. It suggested that an entirely different process was shaping this region of space. Whatever had created this immense stellar trail was unlike anything previously documented, and understanding its origin would require scientists to question some of their most familiar assumptions about how galaxies and the universe itself work. Eliminating the obvious explanations. Whenever astronomers encounter something unexpected, they don't immediately jump to extraordinary conclusions. Science works by testing the simplest explanations first and eliminating them one by one. That careful process is exactly what began after researchers identified this remarkable line of young stars. The first possibility was that the object wasn't unusual at all. Perhaps it was simply a very thin galaxy viewed from its edge. From Earth, perspective can be deceiving, and an ordinary galaxy seen from just the right angle can appear as a narrow line. If that were true, the mystery would disappear almost immediately. But the evidence didn't support that idea. By analyzing the light coming from the structure, scientists found that nearly all of its stars shared similar characteristics. They were extremely young, bright, and blue. A normal galaxy is home to stars formed across billions of years, containing a rich mix of young, middle-aged, and ancient stellar populations. This object lacked that diversity entirely. Instead of looking like a mature galaxy, it resembled a giant ribbon of newly created stars. The first explanation was no longer convincing. Attention then shifted to another well-known cosmic phenomenon. Some galaxies contain actively feeding supermassive black holes that launch enormous jets of high-energy particles deep into space. These powerful streams can slam into clouds of gas, compressing them enough to trigger the birth of new stars. Similar events have been observed elsewhere in the universe, making this a reasonable hypothesis. Yet once again, the details refuse to cooperate. If a jet had produced the stellar trail, its shape should have gradually widened as it traveled farther from its source. Instead, astronomers found the opposite pattern. The narrowest region lay at the leading end of the structure, while the broader portion remained closer to the nearby galaxy. Even more puzzling, the strongest signs of energized gas were concentrated at the very front, rather than near the galaxy where such activity should have originated. Every new measurement weakened the jet explanation. With both leading theories failing to explain the observations, researchers found themselves facing an uncomfortable reality. The evidence pointed towards something entirely different, something that no telescope had clearly revealed before. The mystery wasn't getting smaller, it was becoming even more extraordinary, forcing scientists to consider an idea that had existed mostly in theoretical calculations rather than direct observation. Could a black hole be racing through space? With the most familiar explanations ruled out, astronomers were forced to consider a possibility that sounded almost unbelievable. What if this enormous trail wasn't a stationary object at all? What if it had been created by something moving through space at incredible speed? Among the more daring ideas, one stood out. It suggested that the mysterious structure might be the wake of a runaway supermassive black hole, an object so massive that it could outweigh millions of suns, yet traveling fast enough to escape the galaxy that once held it. For years, this concept had existed mainly in theoretical physics. Computer simulations predicted that, under the right conditions, a supermassive black hole could be ejected from its home galaxy. But despite decades of research, no one had ever found convincing observational evidence that such an event had actually occurred. The theory begins with one of the universe's most dramatic events, the merger of two galaxies. Nearly every large galaxy is believed to host a supermassive black hole at its center. When galaxies collide, their central black holes gradually spiral toward one another over millions of years, before finally merging into a single, even larger black hole. That collision releases an enormous burst of gravitational waves, ripples in the fabric of space-time first predicted by Albert Einstein and confirmed only in recent years. In an ideal situation, those waves would spread evenly in every direction. But nature is rarely perfectly symmetrical. If the gravitational waves are emitted unevenly, the newly formed black hole receives a powerful recoil, much like the backward kick of a rifle after a bullet is fired. Instead of remaining safely anchored at the center of its galaxy, the merged black hole can be launched outward at astonishing speeds. Theoretical studies suggested that these cosmic kicks could accelerate a supermassive black hole to hundreds, or even thousands, of kilometers per second. At those velocities, it could completely escape the gravitational pull of its host galaxy and begin an extraordinary journey through intergalactic space. For decades, this remained an elegant mathematical prediction without direct proof. Now, astronomers were looking at a structure unlike anything ever observed before, a remarkably straight trail of young stars extending across nearly 200,000 light-years. Suddenly, the runaway black hole theory no longer seemed like science fiction. It had become the only explanation that appeared capable of matching the evidence. But extraordinary claims require extraordinary evidence. To find out whether this incredible idea was correct, scientists needed sharper observations, more detailed measurements, and a telescope powerful enough to reveal what Hubble could not. The next stage of the investigation would provide exactly that. James Webb provides the missing evidence. At this point, the runaway black hole hypothesis was intriguing, but it was still only a hypothesis. Astronomers needed stronger evidence before they could claim that such an extraordinary object truly existed. The blurry outlines captured by Hubble had raised the question, but answering it required a much more powerful eye on the universe. That opportunity came with the James Webb Space Telescope. Equipped with advanced infrared instruments and dramatically higher sensitivity, James Webb can reveal details that were previously hidden from view. When researchers turned Webb toward the mysterious stellar trail, the observations transformed the investigation. Near the leading edge of the structure, scientists discovered a distinct feature that immediately caught their attention: a bow shock. Similar phenomena occur whenever an object moves rapidly through a surrounding medium. A speedboat pushes water into a wave at its front. A supersonic aircraft compresses the air ahead of it. In space, the same principle applies when an object barrels through clouds of gas. Webb's data showed that gas at the front of the trail was being intensely compressed and heated. The atoms there displayed signatures of extreme temperatures, indicating that something massive was plowing through the intergalactic material at tremendous speed. This wasn't the pattern expected from a stationary galaxy or an ordinary jet of particles. It was exactly the kind of disturbance scientists would expect from a fast-moving object carving its way through space. The evidence didn't stop there. Measurements of the surrounding gas revealed abrupt changes in velocity, as though it had been violently pushed aside by an invisible traveler. Behind this compressed region lay the long chain of young stars already identified by Hubble, creating a sequence that fit together with remarkable consistency. First a shock front, then compressed gas, and finally newly formed stars stretching far into the distance. Piece by piece, the puzzle began to make sense. By combining Hubble's original observations with Webb's far more detailed data, astronomers concluded that the mysterious object responsible had to possess extraordinary properties. It was likely a supermassive black hole carrying a mass of roughly 10 million suns while racing through space at close to 1,000 kilometers per second, fast enough to cross the distance from New York to Los Angeles in just a few seconds. For the first time, a theory that had lived primarily in computer simulations appeared to have direct observational support. What once seemed like an impossible idea was rapidly becoming one of the most compelling discoveries in modern astronomy. Yet, an even greater mystery remained unanswered. If black holes are famous for consuming matter and destroying everything that comes too close, why was this one leaving behind a trail filled with the youngest stars ever observed in such a structure? The answer would reveal one of the universe's most remarkable contradictions. When destruction creates new stars, black holes are often described as the ultimate cosmic destroyers. Their gravity is so intense that not even light can escape once it crosses the event horizon. They tear apart stars, consume gas, and reshape entire galaxies. Because of this reputation, they are usually associated with destruction rather than creation. But the object at the center of this discovery told a very different story. Instead of simply swallowing everything in its path, the runaway black hole appeared to be triggering the birth of entirely new generations of stars. At first, this seemed completely contradictory. How could one of the most destructive objects in the universe become responsible for creating something as fundamental as stars? The answer lies in the enormous shockwave generated by its journey through space. As the supermassive black hole races through the thin clouds of gas scattered between galaxies, its tremendous speed compresses the material directly in front of it. This compression dramatically increases both the pressure and temperature of the gas, much like air heating up ahead of a supersonic aircraft. Behind the moving black hole, however, conditions begin to change. Over time, the compressed gas starts to cool. As it loses heat, gravity slowly takes over. Instead of remaining spread out across space, the gas begins collapsing into denser and denser clumps. Eventually, some of those clumps become so massive that temperatures inside their cores rise high enough for nuclear fusion to ignite. The process that powers every star in the universe. One cloud becomes a star, then another follows, and another after that. Over millions of years, this chain reaction can produce an immense trail of young, brilliant stars stretching across intergalactic space. What once appeared to be an impossible line of blue stars now had a scientifically plausible origin. The runaway black hole wasn't creating stars directly. It was creating the conditions that allowed gravity to do the rest. This remarkable process reveals one of the universe's greatest paradoxes. The same object capable of destroying nearby stars and planets can also lay the foundation for entirely new stellar systems. In one region of space, it represents unimaginable destruction. In another, it becomes the catalyst for creation. That realization transformed the discovery into something far more profound than the identification of an unusual black hole. It demonstrated that the universe rarely fits into simple categories of creation or destruction. Often, the two are deeply connected, with one process making the other possible. The next question, however, was just as fascinating. If this extraordinary black hole had been racing through space for so long, where had it come from? To answer that, astronomers needed to follow its trail backward, toward the violent event that launched it on its incredible journey billions of years ago, following the trail back to its birthplace. Identifying the object was only part of the mystery. Astronomers still wanted to answer an equally important question. Where did this runaway black hole come from? A supermassive black hole cannot simply appear in the middle of intergalactic space. Something powerful must have launched it on its incredible journey. Fortunately, the trail itself provided the clues. Like footprints left across fresh snow, the long chain of young stars pointed back toward the black hole's place of origin. By tracing the direction of the stellar trail, researchers followed its path across space until it led to an extraordinary system of interacting galaxies located billions of light years from Earth. This wasn't an ordinary galaxy. The system showed clear signs of a violent cosmic collision. Two massive galaxies had passed through one another and were in the process of merging into a single, larger galaxy. Such mergers are among the most energetic events in the universe, reshaping billions of stars over millions of years. During these encounters, gas clouds collide, star formation accelerates, and the galaxy's central black holes are gradually drawn together by gravity. Each of those galaxies originally hosted its own supermassive black hole. As the galaxies merged, the black holes began an immense gravitational dance, orbiting each other while slowly spiraling inward. Over millions of years, the distance between them shrank until they finally collided. When two supermassive black holes merge, they release an enormous amount of energy in the form of gravitational waves, ripples, that travel through the fabric of space-time itself. If those waves are emitted equally in every direction, the newly formed black hole remains near the center of the galaxy. But if even a slight imbalance occurs, the escaping energy acts like the recoil of a cannon, delivering an enormous kick to the merged black hole. Computer models have long predicted that this recoil can be astonishingly powerful. Under the right conditions, it is capable of accelerating a supermassive black hole to speeds of around 1,000 kilometers per second, fast enough to escape the galaxy's gravitational pull entirely. Everything about the observed trail matched that prediction. The direction of travel, the estimated speed, and the location of the galaxy merger all pointed toward the same conclusion. Rather than remaining at the center of its newly formed galaxy, the merged black hole had been violently ejected into intergalactic space, beginning a journey that would continue for billions of years. Instead of wandering silently through the cosmic void, however, it left behind a remarkable signature. Every light year of its path recorded the history of its escape, preserving the evidence in the form of a vast trail of newborn stars. For astronomers, this was more than the solution to an unusual mystery. It was one of the strongest real-world demonstrations that galaxy mergers can reshape the universe in ways previously seen only in theoretical calculations. A prediction that had existed on paper for decades now appeared to be unfolding across hundreds of thousands of light years, offering a breathtaking glimpse into the dynamic and ever-changing nature of the cosmos. A discovery that changes galaxy evolution. For generations, astronomers have worked under one fundamental assumption. Every large galaxy is anchored by a supermassive black hole at its center. These enormous objects were believed to remain there for billions of years, influencing the movement of stars, regulating the flow of gas, and helping shape the evolution of their host galaxies. This discovery challenges that picture. If a supermassive black hole can be ejected from its galaxy, then galaxies may be far more dynamic than previously imagined. Instead of being permanent fixtures, these cosmic giants could occasionally become travelers, leaving behind galaxies forced to evolve without the massive object that once dominated their cores. That possibility raises an entirely new set of scientific questions. How does a galaxy change after losing its central black hole? Does star formation increase or decrease? Can another black hole eventually replace the missing one? These questions were rarely considered before because astronomers had little reason to believe such events actually occurred. Now, they have become active areas of research. Researchers also began searching through years of archived telescope observations, looking for signs that similar events had happened elsewhere in the universe. Rather than focusing only on galaxies with obvious central black holes, they started paying close attention to systems that appeared unusual or incomplete. Several intriguing candidates quickly emerged. In some galaxies, the central black hole appears slightly displaced from the surrounding stars, almost as though it is still moving after receiving a powerful gravitational kick. In others, astronomers have struggled to locate the massive black hole that theory predicts should exist at the galaxy's center. While none of these cases are as convincing as the newly identified runaway black hole, each one hints that such events may not be unique. If future observations confirm more examples, the implications will extend far beyond a single discovery. Galaxy evolution models may need significant revision. Computer simulations that assume black holes remain permanently fixed at galactic centers could require major updates. Even our understanding of how galaxies grow over billions of years may need to be reconsidered. Perhaps the most exciting possibility is that runaway black holes are not exceptionally rare at all. Galaxy mergers occur throughout the universe on a regular basis, and every major merger creates another opportunity for a gravitational recoil powerful enough to launch a black hole into intergalactic space. If that is true, countless wandering black holes may already be traveling through the cosmos, quietly reshaping their surroundings. The remarkable trail observed in this discovery may represent not an isolated event, but the first clear example of a phenomenon that has been unfolding across the universe for billions of years, hidden in plain sight until our technology became advanced enough to recognize it. The hunt for more cosmic wanderers. One confirmed discovery is exciting, but for astronomers, it also marks the beginning of a much larger search. If one runaway supermassive black hole has been found, the obvious question is whether there are many more hidden across the universe. The answer could dramatically reshape our view of the cosmos. Modern observatories are now better equipped than ever to find these elusive objects. The James Webb Space Telescope continues to capture incredibly detailed images of distant galaxies, while future missions, such as the Nancy Grace Roman Space Telescope, will survey vast regions of the sky with remarkable precision. Instead of examining one target at a time, these observatories will allow scientists to search millions of galaxies for the subtle signatures of runaway black holes. Technology is also changing the way discoveries are made. Astronomers are increasingly using artificial intelligence and machine learning to analyze enormous amounts of telescope data. Rather than relying solely on human eyes, advanced algorithms can scan billions of observations, searching for faint stellar trails, unusual shock waves, and other patterns that might otherwise go unnoticed. What once required years of manual analysis can now be completed in a fraction of the time. Every new detection would help answer some of astronomy's biggest questions. How often are supermassive black holes ejected from their galaxies? How many are currently wandering through intergalactic space? And how much influence do these travelers have on the evolution of galaxies and the birth of new stars? Each discovery adds another piece to the puzzle. Instead of seeing runaway black holes as rare cosmic curiosities, scientists may eventually recognize them as an important part of the universe's ongoing evolution. As telescopes become more powerful and data analysis continues to improve, the chances of uncovering more of these extraordinary objects have never been greater. A universe more dynamic than we imagined. The discovery of a runaway supermassive black hole is far more than an unusual astronomical observation. It reminds us that the universe is constantly rewriting the rules we think we understand. Every time scientists develop a clearer picture of how the cosmos works, nature reveals another phenomenon that challenges long-held assumptions. For decades, black holes were viewed almost entirely as agents of destruction, objects that consume matter, trap light, and reshape everything around them through immense gravity. Yet this remarkable traveler has revealed a more complicated reality. As it races through the darkness between galaxies, it appears capable of creating the conditions that allow entirely new generations of stars to emerge. That contrast is one of the most fascinating lessons in modern astronomy. The same force capable of tearing apart celestial objects can also help build the raw materials for future solar systems. Destruction and creation are not always opposites in the universe. More often, they are part of the same ongoing cycle. Perhaps the greatest significance of this discovery lies not in a single runaway black hole, but in what it represents. If one hidden cosmic wanderer has already been found, there may be many more waiting to be discovered. Each new observation has the potential to reshape our understanding of galaxy formation, black hole physics, and the evolution of the universe itself. As next-generation telescopes continue exploring deeper into space, scientists will almost certainly uncover new mysteries that today's theories cannot fully explain. The universe has repeatedly shown that it is more complex, more dynamic, and more surprising than we ever imagined. And that may be the most exciting part of all. Somewhere beyond the reach of our current maps, another unexpected discovery is almost certainly waiting. Another object may be traveling silently through the darkness, carrying clues to questions we haven't even thought to ask yet. Every image captured by our telescopes is another opportunity to uncover something extraordinary. For Nebulix, that's what makes space exploration so compelling. Every mystery solved opens the door to countless more, reminding us that the universe is not a place we've finished exploring. It's a story that is still being written, one remarkable discovery at a time.